The problem we are solving is of power supply and air pollution. Nigeria and Africa as a whole has an unreliable power sector, leading to the dependence on carbon-emitting generators, which in turn contributes to our ever-increasing health challenges caused by air pollution. Our solution to this is a vertical axis wind turbine integrated with a flywheel energy storage system. Our model enables us to generate, output, and store clean and renewable electricity, simultaneously ensuring a smooth and undisrupted power supply, as it also offers significant benefits over other similar and non-similar electricity systems. Solar power, for instance, is not 100% reliable, does not work at night, and mostly have 15 to 20% efficiency. Conventional wind turbine systems usually have unreliable outputs and battery costs are high. Our model solves these three problems: interruption, costs, and efficiency. Our model integrates a flywheel directly into the wind turbine's transmission and stores kinetic energy while it spins. This is beneficial as there are no energy conversions and therefore minimal efficiency losses. Our flywheel spins in a vacuum chamber and on magnetic bearings to address both air drag and friction, enabling our storage approach with 99% efficiency and a total cycle efficiency of 95% as opposed to the 72.5% of batteries. The theory behind our model is based on dynamics of fluid. Our aerodynamic blades have been optimized for the best lift-to-drag ratio, angle of attack, and chord length. We used airfoil FFAW3-211 for our blade's aerodynamic profile based on an established research. The flywheel was shaped and optimized using the theory of moments of inertia, as its mass was shifted far from the flywheel center to achieve the greatest moment of inertia. Autodesk assisted us with tools that enabled the calculation and mass distribution of the flywheel for the greatest energy storage for the least materials and cost. Presenting you our peculiar model, an innovation of a highly efficient energy storing wind turbine. It is composed of a wind turbine, a differential, 2 planetary gears, 4 sets of generator coils, 4 sets of bar magnets, shafts, 2 clutches, 2 torque converters, and 4 magnetic bearings. The wind turbine has both its shafts and supports made of carbon steel and its lightweight blades made of carbon fiber. It is connected to a differential's input gear. The horizontal steel shaft from the differential is connected to a planetary gear whose output shaft is then connected to the first generator. The generator is then linked to a clutch to disconnect the wind turbine's transmission from the flywheel at times of lower wind speeds to avoid energy loss stored as momentum in the flywheel. Next is the torque converter, which allows for the reconnection of the clutch without shaft fractures. The torque converter is then connected to a flywheel that spins in a vacuum and on magnetic bearings, minimizing energy losses resulting from air drag and friction. A second generator permanently connected to the flywheel then generates desired amount of electricity by simply charging the solenoid wound on the poles. Our target population are countries across Africa worst hit by the lack of electricity and the health hazards of diesel and petrol generators in overcrowded places. We have developed a working digital prototype using Autodesk Inventor. We plan to develop a physical prototype and pitch it to electricity generating companies to achieve partnerships for the product's commercialization. Then we will launch a startup selling our products. Now, after these years of developing and validating our projects using Autodesk Inventor and backed by scientific principles, we are confident that our project is viable and is a perfect fit for the top prize in this competition. Thank you.